So our problem was that we had to modify the existing test stool.
We just, the whole point of our project was to modify the existing design
To enable accurate characterization of the solar panels.
At first we were using a BP solar panel, which is considerably smaller than a Kyocera solar panel, so we had to change our designs accordingly.
Our criteria was that the tool must be manually adjustable. Our goal was to make it so 2 people can adjust this tool. It must be mobile so we can move it around. We added wheels to our project. It must be secure, adjustable, and stable while testing is in process. The unit must be full top and bottom, so both parts are parallel. This is for storage purposes only. The attachment arm mount and attachment arm must form an isosceles triangle. We did this so we can calculate the map and the angles for which the sun was going to reflect on our solar panel. Must be clearance for cables. We designed this in the top panel. There's a hole like right in the middle, so cables can go straight through. And the covers must be made for PV panels, so it would eliminate electricity generation before and after testing.
We wanted to use the least amount of materials possible in order to cut costs while still maintaining a strong design.
Our design is basically simple, effective, and innovative.
And our main goal is to make a design that's simple, effective, affordable, and easy to move.
This is a website in which we found that's created by NASA. And if you input the longitude and latitude of the school and it set the time or whichever the date, these are all different constraints. It will tell you the apparent sunrise, the sunset, and the current sun position.
We went through the whole brainstorming process
with so many different ideas that we didn't know which formula to use or what kind of calculations to use.
We changed our designs numerous times so that this way we could find the one that was the most accurate design to fit the criteria.
Since an engineering design is not always complete, you can always change.
But in our final design, we realized that the vertical poles and the bottom panel create a right angle. So I used CTEA to find the lengths of each pole.
I had to do a kind of extra math since I had to use arc length, since our arms were not straight.
The adjustment arm connecting the bottom panel to the top panel were 40 inches. The panel on top was also 40 inches, so that made it equally so we could use the law of cosine.
And we had to project the angle out to the vertex, which is shown in the calculations. And from that, we based our entire hinge on it. So once we redid those calculations, we realized that the problem just simply could be fixed by decreasing the angle, the length of the smaller leg on the hinge.
And I use the law of sines to find that length, and that's the length that the angle, the vertex of the angle to where the hole is supposed to be, where for the arm to raise the solar panel up.
The thickness of the bottom panel, it's not thick enough. It's only 3/4 of an inch. So the vertical pole won't be able to be securely attached to the bottom panel. So then we came up with adding a 2x4 piece of wood at the bottom of the bottom panel so that the vertical bar could be attached to that piece so that it's secure.
We created a new type of a hinge. We're using a pin and block.
I designed the barn door hinge. It has 3 parts to it. The 2 sides of the hinge and the pin.
The position that they have to be, it has to be smaller. The knuckle itself, and the knuckle itself wouldn't go inside.
The solar panel bed is moved on an angle. The solar panel won't slide out. It'll be locked in.
Come back and hold each angle, and basically it'll be held by gravity by the weight of the solar panel itself.
Go back in and fix the whole dimensions, and so there was enough room for the axle and the bushing to fit.
And the X-frame connect to each other. The X-frame is to keep it stable from leaning back and forth during the process of getting the required angles.
And I actually called the company and see if they can send me a 3D drawing of it. The problem was we didn't understand what the nodes meant. And this drawing explains what the nodes mean.
We shared our information and files using a website called Dropbox. What it is an online storage system where you can just put files and you can create a shared folder where everyone in a group can share those different files.